Welcome back everyone to another episode of the Doom 3D series, and in this video we are gonna set up an input system for our game. So we are gonna go ahead and implement a kind of wrapper around the GLFW input system. So we'll create input.h and input.c, and inside of input.h we are gonna of course include our GLFW header here, and we'll need to define a macro called GLFW include none here to make sure it does not include any OpenGL headers, which might cause some problems because it will include the gl.h header and not the glue.h. And in here you can see I'm gonna go ahead and paste this button enum structure here, which will basically contain all of the buttons including the keys and the mouse buttons, and we'll use this kind of to access it so that we can like get all of the stuff here easier. And now for testing this, we are now for the actual getting this state of these buttons and things, we are gonna go ahead and implement a couple of methods. First is gonna be get mouse but if button pressed, and the second is gonna be get mouse position. The third one is going to tell us whether the mouse is captured, and the fourth one is going to set the mouse to be captured. And we are going to go ahead and of course include vector.h up here as well so that it doesn't give an error, and yeah, that works. So we're going to go ahead and copy this under input.h. we're going to include input.h, input.c we're going to include input.h, and then we are going to include glfw, and then we are going to go ahead and paste all of this here, and we're gonna go ahead and implement these one by one. So for the first one, which is the input press, first of all we'll need to have some variables here. The first one is gonna be a glw window pointer, the static one, which is gonna be our window, and then we have got our mouse position, and after that we are going to have an array of integers representing the actual state of our buttons. So for each button we'll have one element, and it will use button count for the actual size of the array. And when button pressed, we are going to make sure that the button is within bounds, so it's greater than or equal to 0 and it's less than button count. And if that's the case, then we are going to return it from our array, else we're going to just return 0 like that. For the mouse position, we are going to just go ahead and return the mouse position. And for the mouse captured function, we are going to use the glfw get input mode function to get the mode of our cursor, and if that's equal to disabled, which means that the cursor is disabled, which essentially means that it's captured, then in that case we are going to go ahead and return true, else we're going to return 0 or false. So we are going to use we actually need to put return here. And for set mouse captured, you can imagine that it would be very similar, except that well, actually we need to change the signature of this. It needs to take a variable, a argument called is mouse captured, which will actually represent whether it's captured or not. And then we are going to use glfw set input mode to set this, and if this is true, then we are going to set it to disabled, else we are going to set it to normal. So if our mouse is captured, then disabled, else we are going to set it to normal, like that. And another thing is that this actually needs to be void, not an int, and we're going to change this here. Anyways, you can see that that sets the basic things up, and this actually needs to be greater than or equal to 0. And now we are going to add another function for initializing our input system, which will take a pointer to a glfw window. And in here we are going to just go ahead and set our global window variable to this pointer that we get, and we are going to go ahead and save this, open a main.c. In here we are going to remove these unnecessary includes. Then we are going to go down here, and well, you can see we are initializing everything here. Well, let's go up here and initialize our input as well, and we'll pass it our window. Now we just need to set up some other things which are going to be callbacks for our input. So as I said, glfw will use a callback based system, so we'll create 3 callbacks here for the key callback and the other ones as well, mouse button callback and mouse position callback. We'll generate currently empty implementations in here, and now let's go under main.c and actually set these callbacks. So we're going to use glfw set key callback and pass it the function pointer of the input key callback function, and then we are going to use the glfw set mouse button callback and pass the mouse button one similarly. And remember, we are using function names here to pass a function pointer, not actually calling the function. And then we are going to use set cursor position callback, and we are going to set the position one as well. Now we are now supposed to actually implement these callbacks to store them in the state variables that we have got. So we'll start with the simplest one, which is the mouse position. We'll just set the x mouse position to this and the y mouse position to the y, and that's pretty simple. Now for the key and button callback, it's going to be more complicated. We'll first make sure that our key is not invalid, and if it's valid, then we need to have a way of translating this glfw key into the key that is represented in our button structure. Okay, so for that I'm actually going to paste this whole array here, which is going to represent a mapping from GLFW keys to our buttons and also GLFW mouse buttons to our buttons. And yeah, we're going to just hardcode that, and after that with the key callback we can just make sure that our key is valid, and then we are going to use this key mapping thing that we created. So we will use our key mapping and we'll give it our key, get the index, then we'll put that index in our buttons, and if the action is released then we are gonna say 0, else we are gonna put 1 in there. Now for the mouse button callback, we are gonna paste the same thing here, except that we are gonna use button here, and we are gonna use our mouse mapping, and we are gonna pass it our button, and yeah, that's the rest of the code is pretty much the same. With that, we should have our input ready, and if I run make, I'm gonna just press some buttons and make sure I don't get a seg fault or anything, and with that we can say that we have got that done, and we can start using this inside of our engine. So in here we are going to define a player speed and add some movement to our camera. So we are going to define it as 5 for example, and then we are going to go here and we are going to, in the update function, we are going to check if our key, if our button is pressed, which is going to be our W1, which means moving forward. Then we are going to set the camera dot position to, we are going to add first of all add to our camera dot position. So we are going to add the forward vector of the camera, and we're actually going to go here and create a variable called speed, which will be our player speed. However, if the shift key is pressed, then we are going to increase that. So if the shift key is pressed, we are going to make it player speed multiplied by 2 or 3, for example 2. We are going to have it at 2, and after that we can go here and we need to multiply this by speed. Of course we'll need to use vec3 scale function, so we're going to go here, call vec3 scale, and with our camera dot forward and our speed multiplied by the delta time, and we can just multiply the delta time by the speed here directly. We don't need to keep multiplying it every time, so like that. And yeah, that's going to get the first part here done, and I'm going to go here and paste the backwards moving as well, except the only thing that will change is that we'll use negative speed. You could also use vec3 subtract, and with that you can see I can go forward and backwards with my camera here. And now we need to go ahead and add sideways movement and other stuff. So for that we are gonna go ahead and add A and D keys here, and all of the code is gonna remain same, except that we use the right vector instead of the forward vector now, and all of these have been calculated already. So yeah, that should work. Of course currently we can't actually look around, we can only move around. So in order to add looking around, we are going to go ahead and we are going to define a vector 2, which will represent our last mouse position when we have got our mouse captured, and we'll only move when the user, we only look around when the user presses the right mouse button and the mouse is captured. So we are going to check if the right mouse button is pressed, which means the user wants to look around, and if that's the case, then we are going to go ahead and first of all check if the mouse was not captured before. If it was not captured, this is the first time, so we are going to set the mouse to be captured. Then we are going to set the last mouse position to, well, whatever this mouse position is, and then after that we are going to make sure that if the user is not pressing that and our mouse is captured, then we are going to set it to be not captured. And you can see that the mouse capturing is working here. However, of course currently nothing else happens, so we are gonna go here. We are going to create a vector 2, which will be the mouse position, or we can call it current mouse. So we'll get our current mouse position using the get mouse position function, and then we'll calculate a delta variables, delta x and delta y, using current mouse position and last mouse position. We are going to subtract these, and yeah, like that. And actually let's just put these on separate lines, it kind of looks ugly like this. So with that we should have these two calculated, and now we can use them to increase the pitch and yaw of our camera. So let's start with the yaw, which is going to be represented by the x of the mouse. So we are going to just say dx multiplied by our mouse sensitivity multiplied by the delta time. Now for the mouse sensitivity, we are going to go up here and add a new macro here, and we're going to just define our mouse sensitivity to be 0.05, because we are in radians, we need this to be very low. And after that we are going to go here, and actually I spelled it wrong, and with that we should have this working, and let's run make, and you can see that it will kind of goes out of control. The reason is that we need to reset our last mouse position to the current mouse, and now you can see I can move around and it seems to work quite well. And yeah, that's actually pretty awesome. So we are going to close this here, and we are going to add pitch here as well, which is going to be presented by delta y. And now if I run this, you can see that well, it kind of works, but it's inverted. So we are going to change our delta x and delta y, the order of the calculation of these, so that they are not inverted anymore. And now if I go ahead and run this, I can look around and it seems to work quite well, and I can move around as well, and we've got a fully 3D moving camera here, which is pretty awesome. So that means that our camera system is working. We can move around and we can do everything that we want to, and in here we make sure that our pitch is kind of limited so that we cannot like look more than 90 degrees up. So we're going to use the max and min to just clamp the pitch, and we're going to add this small offset to prevent any rounding errors. So with that we can just make sure that our pitch always stays within range. The yaw of course does not need to be limited. So now you can see I cannot look beyond a certain angle. So with that we have got our looking around and movement completely working. Alright guys, so this is pretty much it for this video, and I'll see you in the next one, in which we'll start, instead of rendering any quad, we'll start to render our actual levels in 3D. So that's going to be a pretty exciting episode, so stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.